This is Algebra 1, Semester 2. It's the third unit called Quadratics. It's the sixth lesson within that unit called Factoring Polynomials Completely Practice. It's on creatormath.com under the Algebra tab. Here are the directions. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for these pages. Remember, these are not notes. These are practice problems. The notes have a lot more background for this topic and for this lesson. It's, of course, on creatormath.com under the Algebra tab. So, instructions. Factor the following polynomial completely, x squared plus 6x minus 27. So, we're going to go any means possible to run through these. The basic rule is with simpler trinomials like this, and remember, we're dealing with a quadratic because of the power 2. The simple thing is what two numbers when multiplied equal the tail, but then added equal this middle value. So how about -9 and +3? That gives you a -27 when multiplied, but when you add it, you get a -6. So let's reverse the signs. Let's say 9 times -3. Now I still get a -27 when I multiply them, but when I add them, I get a 9 minus 3, which is a 6. So that's good. It's this one right here. Let's divide it into x plus 9, x minus 3, 2, binomials, because there's two terms in the expression, and you're multiplying two binomials to create a quadratic. There's 4 multiplication steps is the easiest way. I remember that it's called a quadratic. And so you have x minus 3, x plus 9. That's the factoring. Okay, let's see here. Factor the polynomial. What two numbers equal 48? How about 6 times 8? 6 and 8 is 14, but it's negative. So how about -6 and -8? -6 times -8 is a positive 48 when multiplied, and when added is a -14. So this is it. So x minus 6, x minus 8, they need to be parentheses to show they're being multiplied. Two binomials being multiplied, x minus 6, x minus 8. What two numbers when multiplied equal 45? How about 5 and 9? If it's +5 and +9, it would be a +14 when added, but how about -5 and -9? So x minus 5, x minus 9. And I'm going quickly because we've been through a bunch of these on prior lessons, so make sure you've gone through those. What two numbers when multiplied? 6 times 7, and it's 13. X plus 6, x plus 7. Oh, they got a z going in here. 15. 3 times 5. Z plus 3. Z plus 5. And when you add the 2, you get 8. So what two numbers were multiplied? I got a 15 when multiplied, and a positive 15 and a positive 8 when added. So far, they're giving me easy ones. Let's see here. Oh, here we go. Now we step up. We got a -9 out front. So I'm going to cheat a little. Let's look at our answer choices, right? I do see they're pulling out a 9 out of all the terms in these answers. However, can I pull a 9 out evenly or divide 60 by 9 evenly? I don't think so. I don't know that multiplication table. So I'm going to get rid of these two answer choices. Looks like I'm pulling a 3 out, and it's a -3 out front. So let's pull a -3 out or divide each of these by a -3 each term. And before we do that, let's go to the just keep it the way it is. So -9x divided by -3 leaves you with 3x squared. A -60x divided by a -3 is +20. And a -36 divided by a -3 is a +12. So let me rewrite this a little bit cleaner. What two numbers when multiplied together equal 12 and add to this one, but because of the lead term, it's going to be a little bit more complicated here. Let's start with the 3x here and an x. That way when they multiply, we're going to have 3x squared. That takes care of that. What if we have a +3 and a +4? Doesn't that multiply to be +12? Yes. And a 3x here and a 12x there would give us 17x. So what if you reverse this? Let's put the 4 here and the 3 here. This would be a 9x and a 4x. So I'm not liking any of these so far. we need a bigger number. So look, this is 4x and this is 9x. That would only be 13x. And even when we reversed it, we need a bigger number. So let's say we multiply, let's make this a 6. And let's make this a 2. So 2 times 6 is still 12. 3 times 6 is 18, and 2 times x is 2, so that'd be 20x. So I like this one right here, so let's clean it up a little since I wrote all over it. And what I'm doing is FOIL in my mind pretty quickly, right? I'm taking these two numbers first, 3x squared, that matches that. I'm taking the tail, 12, that matches that. Now it's just these two that combine in here. I do a 2x here, and 3x times 6 is 18x for 20x. And I need an x here. There we go. Getting a little bit fast and loose here, but I think that's it. There we go. X plus 6, 3x plus 2. My other trick is going to be, and we'll do it down here on a later one, we'll just go backwards from one of the answers. So I don't see that you can pull out, for example, see how they're pulling out 4 out of these? You can't pull 4 out of a 15, so these are out. Let's just try FOIL, right? This would be 16n squared. That's good. This would be minus 15. That's good. We'd have a minus 20n and a 12n, so a minus 8n. So we're basically doing FOIL quickly in our minds at this point. And if you've practiced enough, you can do it. If not, you're going to write out the whole thing. You're going to first, outside, inside, last, and just multiply it and see if it matches up. All right, a couple of these are pulling 4 out, but you can't pull 4 out of a 21. Gone. If we do FOIL on these, let's do FOIL on the wrong one. Let's do FOIL on this one. This is going to be 20n squared. Well, that matches. Let's do the tail, minus 5. Well, that matches. But notice what they've done. They shifted the sign here from one to the other. So probably what we're going to end up with is instead of a minus 21n, I bet we end up with a positive 21n. So outside would be a minus 4n. Inside would be a positive 25n. 25n minus 4n is positive 21n. So sure enough, this one generates almost the same answer, but it's a positive right here, and we know that's not acceptable. So go back to this one. Let's just do the inside. It would be a negative 25n plus 4n would be a negative 21n. And again, we know FOIL well enough by now from all the other lessons in this unit that we are doing it in our minds. Go back and see the original units if this is too advanced. Go back and practice all those problems. Okay, so I don't see that we can pull a 2 out of a 7. Gone, gone. It's going to be one of these. I bet they're going to look very similar, and I bet one of them is going to have a positive 7x, the other a negative 7x, I bet. So sure enough, this becomes 6x, and this becomes 7x. So I like this one already, just because I'm doing parts of the FOIL. FOIL would be 2x squared up front, check. 3 on the tail, check. A 6x and a 1x do add to a 7x. I would like to pull 6 out of this thing because I see this 540. That's got to be a 90. So if we pull 6 out, we get a v squared plus v minus 90. When I look at these things, you know, anything with a 0 on it means 9 times 10. And if I need a positive, can't I make that a positive 10 and a negative 9? And when I add these, won't I get a positive 1? So sure enough, v plus 10, v minus 9, and the 6 out front, v minus 9, v plus 10. And I know that when I FOIL this, I'm going to go back to this. And when I multiply 6 across each one in the distributive fashion, I'm going to go back to the original problem. This one I'm starting to recognize as special products. I already know this is x plus 11, and I know there's 2 of them. I know it's squared because it's x plus 11 times x plus 11, because when you FOIL that, you get the 121 on the tail, the x squared in the front, and you add 11x plus 11x for the inside term, 22x. I already know the answer. All right, this one's the reverse of it with a minus, so it's going to be x minus 11 to the power 2. Go back and see prior problem sets. They're recurring. That's how I know this. I know what's going on here. It's x plus 11, x minus 11. The fact that these two signs are switched means the middle term disappears. Notice we have an x squared. We have a minus 121 from the tail. But this middle term is missing because 11x minus 11x is 0. Oh, gone. Let's see. X plus 6 squared. Yep, because 6 times 6 is 36. 6 plus 6 is 12. This one's probably a minus 12, so it's x minus 6 squared. These are really simple. Just do the reverse if they don't look familiar to you, and do more practice problems if they don't look familiar to you. How about that? So make sure you're matching up this lesson name, Factoring Polynomials Completely Practice. It's 06 under the Quadratics unit. It's on creatormath.com under the Algebra tab.